Hi, my name is Venkanna, Associate Professor in Engineering College. Now, I want to explain field effect transistors. Field effect transistor, abbreviation field effect transistor, and it can be known as FET. FET. F E T. FET. Field effect transistor. So, the field effect transistor is a semiconductor device in which the flow of current controlled by an electric field. So, it is called as field effect transistor FET. FET is a semiconductor device in which the flow of current controlled by an electric field. So that's why this is called as field effect transistor. In FET, the current is carried by majority carriers. The current is carried by majority carriers. So it is a unipolar device. But in bipolar junction transistor, it is a bidirectional device. But FET is a unipolar device. So here basically FETs are classified into two types. First one is JFET. FET. And second one is MOSFET. JFET means junction field effect transistor. And MOSFET is metal oxide semiconductor FET, field effect transistor. So JFET junction field effect transistor normally it is called as FET, and MOSFET it is also called as insulated gate field effect transistor. MOSFET it is also called as insulated gate field effect transistor. And now I want to discuss field effect JFET, junction field effect transistor. Basically, junction field effect transistor is divided into two types. First one is N channel JFET, and second one is P channel JFET. So here depends on the material used for the channel. These junction field effect transistors are divided into two types. These are N channel. If we are using N type material for the channel, then that is called as N channel field effect transistor. If we are using P type semiconductor for the channel, then that field effect transistor is known as P channel JFET. So basically FET consists of three terminals. What are these? First one is source. Second one is drain, and third one is gate. These three are the terminals. So gate which consists of how many terminals? Source, three terminals. These are source, drain, gate. So N channel FET, the schematic diagram which is represented like this. This is the N channel FET. So this is arrow mark, gate, source, drain. So this is N channel. And P channel, this is source, drain, gate. This is P channel. The arrow mark outward for the P channel. Gate terminal consists of arrow mark. Outward arrow mark indication for P channel, FET, and gate inward, gate arrow mark indicates inward, that is for the N channel FET. So here basically FET consists of three terminals. These are gate, drain, source. Gate, drain, source. These three terminals. So here source it is indicated with S. Source terminal is indicated with S. So the terminal in which the majority carriers enter the semiconductor bar, then the terminal is known as source. So the conventional current entered into the bar at the terminal source S, it is designated or denoted with IS. Source current is indicated with IS, and gate current is indicated with IG, and drain current is indicated with ID. So here basically the current enter from source terminal to the drain terminal. So here the flow of current controlled by gate terminal. So here the gate current is indicated with IG, and drain current is indicated with ID, and source current is indicated with IS. So basically these three are the terminals. So here the indication, the schematic diagram for the FET, field effector transistor, like this. N channel JFET, it is also sometimes called FET. FET is abbreviated as junction field effector transistor, is also known as FET. So that's why these are basically two types: N channel FET, P channel FET. N channel FET looking like this, and P channel FET looking like this. So now here I want to discuss N channel FET operation. So FET operation, how the FET can be operated. Here basically I already discussed that N channel FET, P channel FET. So now here I want to discuss N channel FET. For the N channel FET, take semiconductor bar, N-type semiconductor bar. So this is N-type semiconductor bar. So for the N channel, this is N-type. Though here the taken base material is N-type semiconductor. So that's why this is known as N channel field effect transistor. So for the operation and construction, first we have to take the N-type semiconductor. Here the ohmic contacts, in this side the ohmic contacts are there, and in this side the ohmic contacts are there. This terminal is known as source, and this terminal is known as drain. Okay, and in opposite side doping, this N-type semiconductor material is doped with P-type semiconductor. This N-type semiconductor is doped with P-type semiconductor. This is p-type semiconductor. This is p-type semiconductor and doped with a p-type semiconductor on both sides. So here in between these two, the current electrons, majority carriers in this n-type semiconductor, the majority carriers electrons are flowing from source to the drain through this path in between p-type semiconductors, like this. In between p-type semiconductors, the electrons or current is flowing from source to drain. So here the ohmic contacts are given to these two p-type semiconductors. These two terminals are known as gate terminal. This is gate terminal. These two are given చూడండి. This is p-type material, n-type material. These two are acts as p-n junction diode, and similarly this is p-type material, this is n-type material. So these two are acts as p-n junction diode. So here in between p-type and n-type material, one layer is established. Similarly in between p-type material and n-type material, one layer is established. So this layer is known as depletion layer. Depletion layer is established. So the depletion layer width is increases by applying the reverse bias voltage. So we have to apply reverse bias voltage to the gate terminals. Reverse bias voltage means p-type material. For the p-type material, we have to apply negative voltage. Similarly, for the p-type material, we have to apply negative voltage. So by applying the negative voltage or by increasing the negative voltage to the gate terminal, so the depletion layer between p-type material and n-type material is increases. Then the width in between these two, the width is decreases. Then the current flowing from source to drain is decreases. Why? Because the channel width is nothing but in between p-type and n-type. చూడండి, p-type gate, p-type material, in between these two, the place is known as channel. So through this path only electrons or majority carriers are flowing from source to drain. So that's why this is known as, this area is known as channel. So by increasing the reverse bias voltage, the depletion layer width is increases, and then these two are looking like this. What will happen? The width between these two is decreases. Then the channel width is decreases. Then the amount of carriers, majority carriers flowing from source to drain is reduces. So that's why the current from source to drain is controlled by electric field. So by applying the reverse bias voltage, electric field, so that's why this is known as field effect transistor. So this is the voltage control device. Basically bipolar junction transistor is a current control device, but FET is a voltage control device. So here this is known as VGS voltage. VGS is equal to 0 what will happen when VGS is equal to 0? What will happen? So the channel width is increases. Channel width is maximum. Why? Because when the VGS is 0, so the depletion layer is, the width of the depletion layer is small. So that's why here the channel width is maximum. So the maximum channel width is maximum. So that's why high amount of current is flowing. So that's why high current is flowing from source to drain. If we are increasing VGS, what will happen? If we are increasing VGS in between gate terminals, then the width between p-type and n-type depletion layer width is increases. Like this, and the channel width is decreases. The channel width decrease means, so small amount of current only flowing. So this is the basic construction and operation of FET. So this is n-channel field effect transistor. So for the p channel, same, the n-type, first of all we have to take the p-type semiconductor, and in between these two the doping with n-type semiconductors, n-type material. So then that is known as p channel FET. This is the n channel FET. Thank you.